Hello everyone, welcome to my YouTube channel, and today I'll be talking about advanced RAG concepts like re-ranking, hybrid search and evaluation. So imagine this: if your RAG system retrieved 5 chunks, your LLM used up all of them to generate your answer. But the problem is the 3 of those chunks had nothing to do with the question. So LLM got confused and gave you a messy half wrong answer. So this is the number one problem in production RAG. It's not the LLM, it's not the chunking, it's the gap between what gets retrieved and what should have been retrieved. So in my previous video, I have covered what RAG is and how to chunk your document. So today we are going to the next level. I'm going to show you how to make your retrieval actually good. So using hybrid search, re-ranking, query transformation, and proper evaluation. This is what separates a demo from a production system. So let's move to the new slide. Yeah. So let's understand why basic vector search alone isn't enough. In a basic RAG setup, you take the user's question, turn it into embeddings, and find the closest chunks in your vector database using cosine similarity. So the top 5 chunks get sent to the LLM. Simple, right? But here's where it breaks. The problem one is semantic search misses exact matches. So if someone asks for error code like E4012, for example, the vector search might not find it because it's matching the meaning, not the keyword. So the exact code could be sitting right there in your database, but the embedding model doesn't treat it as important. The second problem that we face is cosine similarity rewards proximity, not usefulness. Just because a chunk is semantically close to the question doesn't mean it actually helps for answering it. Third problem is there's no filtering. Okay, so if your question is about the 2024 policy, but your database has documents from 2020, 2022, and 2024. So the basic vector search doesn't know to filter by date. So it just finds whatever is the closest in meaning. So these 3 problems are why we need the advanced techniques we are covering today. So let's jump to the first topic, that is hybrid search. So hybrid search is one of the most impactful upgrades you can make. The idea is simple: combine 2 types of searches that are good at different things. So one is semantic search, which is your vector search that understands the meaning. It knows that the refund policy and money back guarantee are related even though the words are completely different. And second is keyword search, like BM25, it's a bag of word model that matches the exact terms. So it's great at finding specific names, codes, IDs, and technical terms that semantic searches miss. So hybrid search runs both at same time and combines the result, so you get the best of both worlds, meaning and precision. So next thing that we do here is the reciprocal rank fusion. Why? So now question is, how do you combine this 2 rank list into one? This is where this reciprocal rank fusion comes in. So RRF is a standard method that is used in industry. So here's how it works in simple terms. Each result gets a score based on its rank position. So the higher the rank, the higher the score. Results that appear in both lists get a combined score which pushes them to the top. Okay. And results that only appear in one list still gets included but rank lower. And the formula is even also straightforward. For each result, the score is 1 divided by rank plus constant, usually 60 we use. So you add up the scores from both lists and done. Even research from MegaRag framework showed that hybrid search with RRF reduced hallucination by over 40% compared to a vector only search. So that's massive improvement. So I would like to compare this semantic and keyword before we move forward. So in semantic, what happens is it is a dense and keyword is a sparse matrix. So semantic finds the meaning, paraphrases, related concepts, but misses the exact keyword, rare terms, and acronyms. In keyword search, the exact terms, names, ID codes are found and misses synonyms, paraphrase, and context. Speed wise, semantic is slower because it needs embedding model and plus vector DB. Whereas the keyword is very fast, no ML model is needed. Semantic generally is used in natural language questions, open-ended queries, whereas the keyword is used in technical queries, search by name, code, or ID, those kind of things. So most of the production RAG systems in 2026 use this hybrid search. Even Pinecone, Weavit, and Elasticsearch all support it natively now. If you are only using vector search, hybrid search is probably the single biggest upgrade you can make. You can even use a Splade as an alternative for BM25 for sparse retrieval. It's a learned sparse model that performs better in many cases. So let's move on to next. That is re-ranking. So, all right. So hybrid search gets you better candidates, but even with the hybrid search, the ranking isn't perfect. So the top result might be the third most relevant, and the fifth result might be the actually best one. So re-ranking fixes this. It's a second stage that takes your top results and rescores them more carefully. Think of it as a two-stage hiring process. The first round filters your resume. The second round does in-depth interviews. So re-ranking is the interview. So let me explain how it works. In the first stage, you do a fast retrieval. Okay, we grab the top 50 to 100 candidates. Speed matters here, so there's no perfection needed. In the second stage, the re-rankers take each candidate and score it against the original query. But here's the key difference. Unlike the first stage, which processes queries and documents separately, the re-ranker looks at the query and the document together. So this is called a cross-encoder. So it takes the full text of the query and the full text of each chunk, feeds them through the transform model, and outputs a relevant score. Because it sees both pieces at once, it understands the relationship much better than a by-encoder that processes them separately. Yeah. Some of the popular re-ranking models, as you can see below, are Cohere Rank, MS Macro Mini LM is there, BG Reranker V2 is there, ColBERT is there, Gina Ranker is there. They have a lot of strengths that and pros and cons here. So let me explain one by one. So Cohere Rank Rerank is a API. It's a cross-encoder API. Here the strength is that it is easy to use, strong accuracy is there, production ready, but it is paid API and has a vendor dependency. In case of MS Macro Mini LM, it's an open source cross encoder. So it is free, lightweight, great for prototypes, but it has a lower accuracy than the larger model. Another comes is BGE Reranker, developed by BAAI, which is open source. It has a strong performance, but needs GPU for good speed. And it also supports the multilingual and it is self-hostable also, for which we need GPU. And next comes ColBERT V2. So it has a late interaction model. It is a late interaction model. So speed of the by-encoder accuracy is near around cross-encoder, but it's more complex setup. There's another thing like Gina Reranker. So it is an API plus open source. It is fast, good accuracy, 8K context support is there, but it is newer and has a smaller community. So let's go to the math that really matters. So here the number that should convince you. So Databricks research shows re-ranking can improve the retrieval quality by up to 48%, measured by NDCG at 10. And in RAG specifically, better retrieval directly means fewer hallucination. So the cost trade-off is real though. Let's say you retrieved 100 candidates and each has 500 tokens. So that's 50,000 tokens through the re-ranker per query. But if the re-ranker helps you send only the top 5 best chunks to the LLM instead of top 5 mediocre ones, you get a better answer and you can use fewer chunks. which means the lower the which means lower the LLM cost. One study showed that 72% cost reduction by re-ranking first and sending fewer better chunks happened. So the cost versus quality insight is gold here. So next comes the query transformation. Okay, now let's talk about something most people overlook completely, the query itself. You retrieve, your retrieval is only as good as the query you search with. So there are some techniques, like one is query rewriting. So the user don't always ask clear questions. Someone might type, why is it slow? When they really mean that what are the common causes of high latency in the payment service? So query rewriting uses an LLM to rephrase the user's question into a more specific search-friendly version before retrieval. So it's a single prompt. Rewrite this question to be a more specific and search-friendly, and then you give the question of the user. So the rewritten query often retrieves dramatically better chunks. Second method is hypothetical document embedding. HyDE, we can say. So this one is clever. HyDE stands for this hypothetical document embedding. Instead of searching with the question, you ask the LLM to generate a hypothetical answer first. Then you embed that answer and search with it. Why? Because the hypothetical answer is written in the same style and language as your actual document. It's closer in embedding space to real answer chunks than the query itself would be. Think of it like if you're searching for a medical database and the question is what causes headache. So the embedding of a short paragraph about headache causes is going to match better than a embedding of a 5-word question. Yeah, this is the second technique. So let's move on to the third technique, that is multi-query or query decomposition. So some questions are very complex. Compare the pricing and the feature of AWS Bedrock and Azure AI, for example, is really two questions, but one about pricing and one about the feature. So the multi-query decomposition breaks this into sub-questions, retrieves for each one separately and combines the result. So the RAG fusion takes this further. So it generates multiple versions of the query from different angles, retrieves for each and merges the result into using reciprocal rank fusion. Same technique we talked about in the hybrid search is applied to the multiple queries. So these were the four techniques that we went through, that is query rewriting, HyDE, multi-query and RAG fusion. So query rewriting is LLM rephrase the more to be more specific. HyDE means LLM generates hypothetical answer, embed that, and then compare. Multi-query is split into sub-questions and retrieve each. RAG fusion is generate query variants, merge with RRF. So query rewriting is best for vague user questions. Okay, and the cost perspective, it is just one extra LLM call. HyDE is a short question, domain-specific content. For those things, it is best used for. Here also the cost is one LLM call plus one embedding. Multi-query, it has complex multi-part questions. So multiple retrieval calls has to make, that's why cost is more. In the RAG fusion, broad queries with multiple angles, we find it is used for that. But the cost is one LLM call plus multiple retrievals can be there according to cost viewpoint. So let's go to the layer 4. That is metadata and context hygiene. So this is the boring one that nobody makes video about, but it's incredibly effective in practice. When you index your chunks, attach metadata, document title, section headings, date, source URL, document type, author, department, whatever you have. This metadata lets you filter results before or after retrieval. If a user asks about the 2024 refund policy, you can filter it to only such document from the 2024. If they ask about specific product, filter the product name. So this eliminates irrelevant results instantly without any fancy ML models. So after retrieval, you can also do context management. Okay, like deduplicate the chunks. Okay, that say the same thing. Compress long chunks by summarizing them. Remove the chunks before a relevant score threshold. This is called the auto cut. Instead of always returning 5 chunks, return only the chunks above a certain score. Sometimes 2 great chunks beat 5 mediocre ones. And there is a uh, concept called CRAG. So correlative RAG is there. So it is a pattern where you check if the retrieved context is actually sufficient before sending it to the LLM. If it is not, you either search again or fall back to the LLM own knowledge. So this is being used in high stake production systems. Corrective RAG. My bad. Next. So let's move on to this how we can evaluate our RAG system. All right. This section actually separates engineers who build demos for engineers who build production system. If you're not measuring your RAG pipeline, you're guessing. And in the production, guessing is not a strategy. So here, as you can see in the slide, the 4 key metrics. There are the 4 metrics you need to take care about. I'm going to explain each one in plain English. So number 1, that is context precision. Out of the chunks you retrieved, how many were actually relevant? If you retrieved 5 chunks and 3 were useful, your precision is 60%. Higher is better. This tells you if you retrieved, is your retrieval is returning junk or not. Second is context recall. Out of all the information needed to answer the question, you how much did you actually retrieve? If the answer requires facts from 4 chunks, but you only found 3 of them, so your recall is 70%. This tells you if you are missing important information. Third is faithfulness. Did the LLM answer actually stick to the retrieved context or did it add things that weren't in the chunk? A faithfulness score of 1 means every claim in the answer can be tracked back to the chunk. If it is low, your LLM is hallucinating despite having context. Fourth one, which is answer relevancy. Is the answer actually addressing the question? You can retrieve great chunks and the LLM might still go on a tangent. This catches that. So TLDR, context precision is retrieval signal to noise. It measures. Context recall is retrieval coverage. Faithfulness is generation grounding. Answer relevancy is generation usefulness. So context pieces are retrieved chunks relevant. Context recall is did you find all the needed information? Faithfulness is the answer based on the context. And answer relevancy is does the answer address the question? So if any of these are low, like for example, context precision is low, you need to improve the chunking, add re-ranking. Context recall is low and retrieve more, like higher K value. Use hybrid search. Faithfulness is low, then improve prompt, reduce noise in context. If answer relevancy is low, then improve prompt engineering and add instructions. As simple as that. So let's move to the tools for the evaluation. So first one is Ragas. Ragas is the most popular open source evaluation framework for RAG. It was recommended by OpenAI at their dev day, and it integrates with LangChain and Llama Index. It uses LLM to score your pipeline without needing a human annotated ground truth. So you can evaluate with about 10 lines of code. That's all. Another framework is Deep Eval. So it has similar metrics but adds debugging tools so you can see exactly why a score is low. Third is Langsmith, obviously from LangChain, gives you a tracing and evaluation in one place. So you can see every step of your pipeline, which chunks were retrieved, what prompt was sent, and how the answers code. And in enterprise teams, you can use AWS Bedrock and Vertex AI have built-in RAG evaluation capabilities now. Yeah. So let me deep dive a little bit in here. So Ragas is an open source LLM based scoring. Okay, so no ground truth needed. Like there are 4 core metrics, easy setup. Best for most of the RAG teams, quick eval cycle. In deep eval case, open source, debuggable also, and explains the score exactly where what is the problem, and custom metrics can be there, and it is also JSON safe. It is best used for debugging low scores, custom use cases, etc. In case of Langsmith, this is SaaS, like tracing plus eval. Okay, so the full pipeline visibility integrated with LangChain is there, and LangChain uses production used for the LangChain users mostly who are familiar with that, and the production monitoring, etc. And another is RAG bench. So this is benchmark database dataset that is that had around 100K examples. So the strength is it that 5 industry domains it covers. Standardized comparison is there. It is best for comparing approaches, academic rigors. Yeah. So let's put it all together. So let me walk you through how all these techniques fit into one production pipeline. Step 1. The user asks a question before you search, you run the query transformation. Maybe you rewrite it to be more specific or use HyDE to generate a hypothetical answer. Step 2. Hybrid search. So you run the both vector search and BM25 keyword search in parallel. You merge the results using RRF. Okay, this gives you around 50 to 100 candidates. Step 3 is metadata filtering. You narrow down those candidates using the date, document type, or source filters. This is fast and cut down the obvious noise. Step 4. Now you will re-rank a cross-encoder score each remaining candidates against the original query. So you take the top 5 to 10 chunks, for example. Next step is context assembly. So you arrange the chunks, maybe duplicates, compress or add summaries, then you build the final prompt with clear instructions. And the step 6 is generation. So the LLM produces a grounded answer based on carefully curated context. And the last step, this is 7, is the evaluation. You measure context, precision, recall, faithfulness, and answer relevancy. You log everything, you iterate. This is not over engineering. DoorDash uses this pattern for their Dasher support. LinkedIn's GraphRag uses re-ranking to reduce resolution time by almost 30%. This is what production RAG looks like. Yeah. So let's discuss about the key takeaway. Let's recap. 1. Basic vector search is not enough. It misses the keyword and doesn't rank well. Use hybrid search to combine the best of semantic and keyword matching. 2. Re-ranking is high impact and low risk. A cross-encoder as a second stage can improve retrieval up to 48%. So start here directly. Next is don't ignore the query. Query rewriting, HyDE, and multi-query decomposition can dramatically improve what you retrieve. 4. Metadata is your secret weapon. Filtering by date, source, and document type is free and incredibly effective. 5. Evaluate everything. Use ragas or Eval or Langsmith or something, and measure context, precision, recall, faithfulness, and answer relevancy. If you are not measuring, you are guessing. And 6. Start simple. Upgrade one thing at a time. Add a hybrid search first, then re-rank, then query transformation. Measure the impact of each change before moving to the next. Yeah. So this is the part of my RAG series. If you haven't watched earlier videos, RAG basics and chunking strategies, Links are right here. And if you want me to code this entire pipeline from scratch in the next video, drop a comment, like, share, and subscribe. I'll see you in the next one.